Okay, I think that is started. So yes, we are the first people to talk, and just to introduce briefly our work, and Ariane is working in my laboratory, and our work is concerned essentially one possibility to make some experiment concerning self-consciousness, and essentially we are focusing on the idea of inner speech. So on the possibility to have a robot able to have inner speech, which is in some sense tightly related to the idea of self-consciousness. Inner speech is considered a signature, one of the possible signatures of self-consciousness. So we are doing some experiment on the possibility to have a robot able to have some model of self-consciousness. This work started together in collaboration with Alan Morin, which is a psychologist from Calgary in Canada, which is considered one of the main experts in psychological aspects of inner speech. So we developed a model, a computational model, together with Alan Morin. And starting with this model, we are doing some experiments, and in particular, this work we are putting together the idea of inner speech with the problem of mirror. So a robot that is able to mirror itself on a glass and to recognize itself, a kind of Gallup experiment, the well-known Gallup experiment of the chimpanzee able to recognize on a glass. And so, Ariane, if you want to start.
Yeah, thank you very much for this opportunity to talk about the work we are doing at the University of Palermo with Antonio related to the possibility of implement inner speech in robot. I share my screen. And do you see my screen at this time?
Yeah.
Yes.
Okay. So with the little presentation, I show this work. Okay. So the inner speech we think is very important for artificial agents for different reasons, because inner speech is strictly linked to self-consciousness, as Antonio shows, but also in humans, inner speech enables high-level cognition. So we think that a robot could be the same things in some sense. So by inner speech, the robot becomes transparent. So a robot could explain what it's doing. In some sense, it could explain the underlying decisional process, and humans know what the robot is doing. And this process makes the robot more pleasant for human self. Moreover, according to the Vygotskian approach of inner speech, that is an internalization process of instructions by a caregiver, we think that human give to the robot the explanation of for solving a task, for example, and the robot becomes able to internalize this explanation and to learn the task to solve the task in a way according to the human needs. So the first step we consider for modeling inner speech in robots is to study the model of inner speech in human, and we choose the Morin model and the Baddeley model. Morin because links inner speech with self-consciousness, and Baddeley because proposes a sort of computational model of inner speech for human. And in particular, Baddeley model consider the inner speech as depending on a working memory system in which there are two main components responsible for inner speech, that are the central executive, that is a master system, and the phonological loop, that is a slave system. And the phonological loop is strictly responsible for inner speech because it contains two subsystems, the articulatory and the phonological store. The phonological store is a kind of short-term memory. So by repeating an item in this loop, so the articulatory produces the item, the phonological store hears the item because it is a sort of inner ear, we are able to memorize that item. So the item passes from the phonological store to the long-term memory, and we memorize that data. So the idea was to fit this model into the standard model of mind that is an important model for the artificial intelligence in general. We consider the articulatory system as a motor component because the robot for producing a sentence uses in some sense a motor, and the other components are integrated in the working memory. So the resulting cognitive architecture is a three-layer architecture. The first layer is the perceptual motor layer, which enables the interaction with the environment, the working memory level, and the knowledge level. The working memory is responsible in this case of inner speech. But differently than the Baddeley model, which consider a simple rehearsal process for memorizing data, we model instead an elaborate rehearsal process. The elaborate rehearsal allows to retrieve further items in the knowledge and enables the robot to make inference in the environment. For example, let's suppose the robot is perceiving an apple. The perceptual motor layer encodes that signals in symbolic form, for example, the words apple and green. They are stored in the phonological store. For example, the central executive could retrieve that the apple is a fruit. So another sentence could emerge, for example, that apple is a fruit. So the new item fruit is added in the phonological store for further elaboration. For example, another fact is that an orange is a fruit, and another sentence emerges. So, for example, robots could search for an orange in the environment. So, by the elaborate rehearsal, the robot interacts with the environment and has a behavior different from the simple rehearsal process. The final step, obviously, is to implement this model, and we choose to use the ACTAR framework because the ACTAR framework provides formalism that allows to model cognitive process in a way that they have many analogies to human cognitive process. So in this way, we attempt to model inner speech in robots as the inner speech for humans. So we fit this architecture in the ACTAR framework, and in particular, we define some types of terms for the inner dialogue. The inner dialogue is a typical dialogue, so it's a sequence of terms. And by Morin, we consider these kinds of this type of dialogue that are social milieu, self-direct questions, self-control, self-focus. Each of these terms has a specific function. For example, by social milieu, we ask to ourselves what the others think about me. The self-direct question allows us to query about a specific situation. The self-control allows us to govern a specific part of our body or our emotions. The focus instead allows us to focus the attention in a part of our body. So this is the good framework because we integrated this ACTAR model with the other typical routines for robots, for example, ROS, text-to-speech, speak-to-text. And an application, obviously, is the mirror self-recognition test, as Antonio shows. We reproduce the test available as the link I attached in this slide. In this test, light is projected in the monkey, and the monkey passes the test if it touches the light in its body when it sees the light in the mirror. Doesn't pass the test if it doesn't touch the light or doesn't do nothing. So we reproduce this situation by inferring this action according to the terms of inner speech by Morin. But instead of considering the projector, a light, we provide the robot with a mask. So by the mask, the robot becomes able to recognize itself in the mirror. After obviously reasoning with inner speech and by using the kind of inner speech I showed previously. So now I give to the robot the floor, and you can hear the inner dialogue because the robot overtly reproduces this dialogue, so you can hear what the robot thinks, what is the discussion of the robot, and moreover, you can follow the model running because this is a double screen and you can see this demo. This is an application of the model and not the final result, we can consider different applications. Okay.
But we can hear the audio. Maybe there is a problem with the audio, Arianna.
I hear my audio. Do you not think the audio?
No, we don't hear. We are not able to hear the audio.
Okay,
Maybe you should.
Tell me.
You
Now?
No.
No. I don't know why the audio is not available. I hear my audio.
Yes, but we don't hear you.
Okay.
No, maybe it's a problem when you share your screen. Maybe there's something with share the screen with the audio or something like this.
Yes, I can try to reproduce by this. I don't know if. You can. Now, nothing.
Anyway, you can comment. You can comment by yourself.
Yes, yes. So
it's
the
a
robot,
because there is the voice of the robot anyway.
Yes, there are also the robot. There is the inner dialogue that the robot produces when it talks to itself. In this case, the control is harm, so it applies a term related to the self-control, and obviously moving the arm, it's do the same thing. And now the robot see its arm in the mirror in front of the mask, so it infers that the mask is of the robot itself. So by this this view, it allows to, in this case, the paper summarizes all fact in the sense he considered the fact that he see a paper like him, and moreover, it has a mask as the robot in the mirror. He looks around for searching for other real robots in the environment, and there are other real robots in the environment. So finally, the robot infer by this inner dialogue that it is the robot in the mirror. So it recognizes itself in the mood of Hamlet. Okay, it's a very so I hand my presentation in this case, and the work we are doing at the robotics lab for this kind of self-consciousness related to the inner speech. Thank you for your attention.
That's great. Thank you, Arianna.
Thank you.
There's I'm just keeping an eye on the time. We'll have plenty of time at the end to go over to have a
maybe at
maybe
at the end of the discussion.
Yeah. Robin, I think you're up next. If you if you can share your screen.
Yep. Make this work. Great.
Great.
Okay, so this is work that is building off of something that was actually already published in the new Journal of AI and Consciousness. And it started, well, yeah, 10 minutes is not enough time. So mostly what I'm going to end up having to do is gesture toward the argument. I can't really give you a significant amount of the argument in 10 minutes, or at least I can't like set it up and give you the argument. But I'll do my best. Please cut me off, John, if I go past 10 minutes. So I had already like finished writing the original paper when Kate Darling tweeted this: humanoid robots are not useful for anything other than very minor use cases. I will die on this hill. And in general, what I'm going to argue is that, in fact, if our goal is something like consciousness, then humanoid robots are exactly the thing we need to be building, and this is not negotiable. And there's absolutely sort of no attack on Kate Darling here. She does great work. This was just a perfect example that popped up as I was like finishing this paper. And so I'm going to be talking about, actually I have a brief outline. Originally I had background there where I was going to set up the argument, but then I timed it and I said, well, that's not possible. So there's no time for background. Some of these slides I probably will skim over as I look at the clock, depending on what I move quickly enough through, but I'm happy to share the slides so you can actually read the quotes, because a bunch of them have big chunks of text that I won't want to read. But the main thing that I want to do is offer that there is a genuine controversy right now, and it's largely centered around AI ethics stuff, but also it's popping up all over that humanoid robotics are not a thing that we should be pursuing, that in some cases they're calling for bans on humanoid robotics because of the human tendency to anthropomorphize and things like that. So there's this controversy. And then what I want to do is argue that humanoid robotics actually are the exact appropriate thing to be building if consciousness is our goal. And I offer just a tiny sampling of that evidence here. I think when I originally made this outline, I wrote general intelligence, conceptualization, and sociality. I will probably barely touch on conceptualization, and I doubt I will get to either of the others at all, but I'm going to do my best. And I apologize if I talk too fast. That's because I'm from New Jersey and we can't help it. Okay, so importantly, this is not an argument about personhood. There's no claim here about personhood. It's not a claim about moral or legal personhood. A lot of the AI ethics stuff is focused around these things. It's not a discussion of robot rights, and it's only tangentially about AI ethics at all, because that's the center where all these arguments are coming that say humanoid robotics are not a good thing to be doing. And these are all good debates. I don't want to discount any of them. That's just not what this argument is. So the claim that I want to support is that research in embodied/4E cognition and all of its satellite sciences, so all of the different cognitive sciences that feed into this, offer us robust, concrete reasons to believe that our specific kinds of minds are intimately related to our specific forms of embodiment and our specific environments. And we do share a lot of those things, right? Like there are multitudes of human forms, but there are basic things about form and environment that we all tend to share. And this is true of physical, social, and cultural environments. So if your goal is to develop conscious AI, the interesting kind, then humanoid form is the strongest argument for how we will both recognize the system as conscious and successfully communicate in a shared language. And I starred that we, and I'm just going to move right past it. So in 2018, there was a panel at CogX, and it was called "Should Robots Resemble Humans?" So this is just sort of more evidence that there's a genuine debate around this. And I apologize to both Joanna Bryson and Alan Winfield for these screenshots. I wanted to get the closed captioning text more than anything, so I just screenshotted on YouTube when they said the right things. But you can see Joanna says there may be no good way to have human-shaped AI that doesn't, and she finishes that by saying deceive. And Alan Winfield had said, I guess I have to say that robots that look like people worry me a lot. So there's, again, a genuine claim from people who really are, that know what they're doing in these communities, claiming we shouldn't be doing anything like humanoid robots. And this is focused around this question of deception, like, are they inherently deceptive? So I love this quote from McFarland, "Anthropomorphism, the incurable disease," because it shows us that we can't stop anthropomorphizing things. This is a short GIF of an animation from the original Heider and Simmel work from 1944, where a large triangle looks like it's kind of bullying a smaller triangle in a circle and trying to chase them into a box. And even little kids will describe the scene this way. There's sort of no anthropomorphism in here. There's no faces, there's nothing but the vaguest appearance of agency. And we're very happy to attribute mindedness to these things because they look like they're acting that way. And in principle, that does seem kind of deceptive, but I would argue it isn't deception just because humans are being deceived. Just because we can be fooled easily, it doesn't mean someone's intentionally trying to deceive us. And so again, with humanoid robots, it's not necessarily deception. Anthropomorphism, again, I apologize, I'm going to move kind of quickly. even within the scholarly literature on anthropomorphism, we don't know what that word means. And so we use it to mean this entire list of things. We use it when we think a thing looks alive, looks like it has some humanity, some animality, some animism, some sort of mind or some sort of minded behavior. And these are all different things, right? Like something can look alive without looking like it has a mind. Something can look like it has some humanity without even exhibiting minded behavior, right? Just a face. So we use the word anthropomorphism to mean a bunch of different things, and that's problematic. And we can manipulate people with this. So very simple personification. If you give something a name, if you give it a description, a backstory, people will assume that there's something minded there, and this is problematic. Once when I was teaching an AI class, we, to illustrate this, we put googly eyes on a chair in the classroom and we gave it a name. And by the end of the semester, my students were so upset when we had to take those eyes off and just turn it back into a chair. And we really did nothing but give it a name and not even a backstory. So this is all correct. These are real, genuine worries. Da Vinci's Night, if it had ever been built in 1495 when he designed it, it was designed to look like it had features of humanity, features of minded behavior. Sophia the Robot, extraordinarily controversial. Sophia the Robot is problematic because it is presented as though it has a mind and thoughts and language, and it doesn't really have any of those things. So there are real considerations here, real worries. And I don't want to discount those, but those aren't really reason enough, I think, to discount the power of building humanoid robotics. Social robots are allegedly different. And part of that is because when we interact with robots, we produce a certain kind of emotional bond that can be exploited at large scale, which again, I think Sophia the Robot is a good example of this. She is kind of exploiting people at large scale because many people who don't know how it works think that she's just spontaneously answering questions and things on stage, which she's not. So the second part, which is that 4E cognition, embodied, embedded, inactive, and extended cognition, sort of gives us a really good reason to go ahead and actually make humanoid robots in spite of all of these potential problems. I put this list of some of its roots up more just so I could give you places to look, but it's a very rich tradition in cognitive science because of the fact that it comes out of almost every subfield in cognitive science, independently have contributed to this approach. So what is it? So this is from the Oxford Handbook of 4E Cognition that came out a couple years ago. I'm just going to read that middle line. All of these traditional pieces of cognitive science are dependent on the morphological, biological, and physiological details of an agent's body, an appropriately structured natural, technological, it says or, but I would say and social environment, and the agent's active and embodied interaction with this environment. So that's the claim of the 4E cognition. There's all different competing claims about this that spread throughout the literature. But importantly, from what I've seen, there have been brief influences of 4E cognition in robotics, but little to no really deep engagement with machine consciousness research, broadly speaking. And even the most successful robots that happen to cohere with the 4E theory are rarely built from or in consultation with it. And I think that's a mistake. I think if people were paying more attention to the really robust theories coming out of these traditions, they would know that certain aspects of the humanoid form in particular matter for that hopefully emerging consciousness. How am I doing on time? Oh God, I have like 2 minutes, huh? All right, well, I'm gonna move very quickly. So I'm just giving you the briefest hints here. There's lots more that I could say, but I won't. In this case, conceptual metaphor theory is one of the arguments that we might give for 4E cognition's potential influence here. And I put some of Lyra Boroditsky's research up here, where she's talking about the ways we talk about time always center a human body in space in different ways, and indeed cross-culturally in different ways. This is another piece from Boroditsky and Gabby from an Australian Aboriginal tribe who also center the human body in space in order to talk about time, but in a wildly different way. I'll give you those citations if you want them. It's fascinating stuff. but importantly, the embodied basis of abstract conceptualization differs across cultures and always centers the human body in space in specific ways. Gesture work as well, robust ways of understanding how gesture helps us actually conceptualize. So we've known for a long time that gesture helps us express language, but there's beautiful arguments that it actually contributes to conceptualization. And if conceptualization are the building blocks of thought, then any kind of interesting thought that we'll be able to converse with and recognize must start from the same sort of shared embodiment that we have. I wanted to talk about participatory sense making a little. It's probably the most exciting social cognition work I've ever seen, but I'm looking at the clock. And even if I absorb 1 or 2 minutes of Julie's time, I think I'm still really pushing it with timing. So I will just point out that participatory sense making is this robust theoretical framework for social cognition, wherein both autonomous systems, like if you think about two autonomous systems in interaction create a new autonomous system. And it's super exciting, but it requires some sort of recognition of the autonomy of the other. And that again is sort of built evolutionarily into us through humanoid form. Okay, so again, since I think I've used up my 10 minutes, this is the conclusion adjacent slide, meaning I know I can't actually give you the conclusion of the work, but I want to sort of say that this is roughly where I would go if I had, 30 minutes to talk about all this. That anthropomorphism is a real issue. It has real ethical implications. It's likely hardwired into humans via evolutionary history. And yes, it is exploitable by bad actors and requires that engineers and companies are honest about what their robots do and that non-experts are informed about those technologies and their capabilities. That's very important. But humanoid robots, human forms embedded in human societies, cultures, and physical environments are a necessary piece of creating the kinds of minds that humans tend to have. So conceptualization, again, we can study it through language or through gesture or through all kinds of things, shows that built into the way we conceptualize the world are forms of our embodiment. Sociality through inactivism, which again, the participatory sense-making claims are an inactive view of social cognition, reveals that some of this process in this larger dynamic system of social cognition relies on certain kinds of embodiment and certain kinds of environments. Therefore, we should build humanoid robots if we want beings that share our worlds and concepts and are capable of interacting in genuinely social sense-making ways. And again, I don't think this should be super controversial, but it turns out to be super controversial. Sorry, 10 minutes is not enough. Please feel free to talk to me about these other things. And this is my ridiculous citation list. And again, I'm happy to share the slides because I know that time is limited. So thank you all.
Thank you, Robin. Thank you for galloping through you're absolutely right. There's a lot of stuff there. It turns out that we don't have a time problem yet, because the next talk that Florian Kirchner was going to give, that isn't available. Those guys are not available at this time. So we'll go straight on to Eric and Micheline. And you probably have a few extra minutes as well, because Julie isn't available either. So I guess Eric, Micheline, you want me to run the slides, and then when we're ready, we'll switch over to the video, right?
Okay.
So let me get this, I'll just get the slides going here for you. Okay, you should be able to see it now.
Yes.
So go ahead.
Okay, so I apologize. I will not speak as fast as you did. I'm French. So robots and choreography, imitating, improvising, and expressing feelings. It's a kind of contribution to artificial sentience testing. So I am Micheline, I'm a choreographer, and I worked with Eric Soudan from the CNAM and Cedric in France. Why artificial sentience is so interesting?
I move on.
Yeah, you're moving. Page 2. Why artificial sentience is so interesting? Artificial intelligence testing is well explored. Artificial sentience is a new field to be explored. So you have different people working on it. Human and machine coevolution, machine will become sentient, or emergence of the humanitor myth. As Alan Turing did in 1950 with the Turing test, we try to provide a test for artificial sentience. The test is intended to be played by a robot, and why not a swarm of robots in the future? So you can change. So I present you the choreography-based sentience testing. The aim is to introduce a robot in a choreography designed for humans, performed by humans, and based on sentient cooperation between performers. The test phases are launch the choreography with a robot as a performer and an interpreter of the choreography. Verifies the full performance and the inner coordination with a human performance. The purpose is not to fall into mimicry. The test is successful if the robot finds its own way to interpret the choreography within the set of performance. The choreography we use as a test pattern has been carefully chosen for its hidden sentient requirements between performers. So you can change. How do we get there? Serendipity was at work to unexpectedly gather our transdisciplinary team. I am a choreographer and a dancer. Eric is a researcher in distributed systems and pervasive interaction. Micheline and Eric, we met a long time ago. Initial work was to explore different mediation paths to establish a relationship between visitors and artifacts in a science museum. Sentience was a driver for this research. Reality is augmented without any device, only by ourselves, guided by the choreographer hints. And once I presented to Eric the choreography Chemins à coulisses. Chemins à coulisses, it's in French. In a way, it means sliding ways. But it's also a kind of a joke because coulisses in French is backstage in English, but it's not so funny in English. And a coulisse is also, it works as if for a trombone, a slide trombone. So it's something sliding. The overall play was astonishingly very close to a distributed algorithm execution. It immediately stuck to Eric's mind to reproduce the choreography with a swarm of robots. The aim of such a project would be to try to execute Chemins à coulisses as intimately, I made a mistake. The aim of such a project would be to try to execute Chemins à coulisses as intimately close as possible to the dancer's performance. The aim evolved to address artificial sentience. So now some explanation about Chemins à coulisses. Chemins à coulisses as a pattern for sentience testing. We carefully studied how Chemins à coulisses is played, more accurately implemented, and how parts of it work. This dance is a quartet, dance in a square space. There is no music, except the sound of dancers' steps or breathings. The dance is constructed with different parts or patterns which slide in space, but also differ in number of steps according to one's partner. For example, I have 8 steps to do and my partner does the same thing, but he dances 12 steps. In this choreography, certain parts are not totally written. The dancers have to use other abilities than only memory. So next. Mostly, we use a specific sense named kinesthetic. Of course, everybody uses kinesthetic, but we use it on purpose. We feel how our partners behave. We are all related to the others through feelings, including breathing, sound of movements, perception of moving air, and so on. The dance has its own musicality. This means inner rhythm, inner music is inside the movement. The dance is made of all these parameters together. We have to distinguish mimicry from interpretation. If the dancers were to imitate movement and just have to know in which space and at what time to perform them, it would not match with my choreography. Something more subtle is required here. Dancers have to coordinate together without speaking. The 4 dancers create something unique that can only happen through the way they are related, each one with the other, beyond any personal desire. So the dance exists because we are the 4 of us. But to explain it a little in a more concrete manner, we made a short video with my partner, Violette. We are only 2 people, so I think it's more clear to explain you a few things that happen during the choreography. So, John, we can run the video, if possible. We are ready to go, no one says go. We feel it. It's a way to breathe. We instantly decide the speed of the dance, the tempo, then we count it. Here we don't see each other. We imagine how long we need to let the movement develop itself. Finally, we finish together, though we had no external indication. Here we can see each other, but you can observe that we dance the same movement with different energy. Violet is tonic, I'm more fluid. Oh, it's true this way, it could be different another day. Again, no indication to go. We are connected, ready for the movement. Here we can see each other. We are on time, and we let the movement go. We feel it. It's a silent communication. Well, so the future steps are evaluate the feasibility of such a robot and In our humble opinion, it would be possible, but funds required. Find partners to design and implement the robot, teach, train the robot carefully and long time enough to let him know performance techniques. Well, in fact, we need 10 years to be a dancer, so we hope it's shorter for a robot. Prepare the robot to be an interpret, the sentient part of the task. Run the test and adjust its design until the robot succeeds. If successful, try the sentient test with one human and a swarm of robots. So that's it. Eric?
That's great, Micheline. Thank you.
Bam.
Okay.
It fits in very well with the previous talks that we had here.
Yeah.
Yeah. Surprisingly.
Yeah. Yes. Given that nobody saw anybody else's talk beforehand. We're doing very well on time because Julie Carpenter is not available. So the next step was a brief break, but I think we're in a good opportunity here to have a conversation, basically covering all of these last few talks. Antonio.
Yeah, no, I agree with you. We can discuss. I see that even John Salis is not present, if I'm right.
Yes, I've sent a message to him, but he hasn't responded yet.
Okay. So we can have some discussion about these first talks if you want to.
Who wants to kick it off?
Nobody else will. I will. Can everyone hear me okay?
Yeah, just about.
Just about. So I wanted to, in specific, kind of ask Robin, in terms of the questions of embodiment and the networks and the sociality embodiment that you raised. Have you looked at the actor network theory work coming out of STS? Try to see how non-human actors can fit into this network embodiment and sociality and technology matrix that you're talking about.
I got part of that because I think your mic is coming in and out, but I think the question was, have I looked into the social actor theory in STS stuff?
Actor network theory.
Actor network theory. Okay. So probably not by that language, and the STS literature is awesome for so much of this, and that's part of the worst part of like the really best embodiment inactive stuff is that it requires looking at different literatures entirely that I'm used to looking to. I have, so the best of the social cognition stuff at least gestures toward, if not fully engages with asking about non-human animals. Including the participatory sense-making stuff that I talked about. This was originally a Hannah DeJager and Ezekiel DePaulo paper, came out in 2007, and it's not that old, and it has just exploded the literature in social cognition. And even in the original paper, they gesture toward non-human animals and talk about how those other kinds of things might fit into the system. I'm actively working with a collaborator right now on a paper about how robots might fit into this system. So instead of just sort of the initially hard question of non-human animals, we're just skipping right ahead and saying, how would particularly a humanoid robot fit into a system like this? Is it agent enough to create this new kind of agency? But they acknowledge that, yes, animals, of course, count in all different ways. And that was part of that asterisk on the we in the early slide where I said we recognize and communicate. And I don't really want to try and unpack that because there are so many things that don't fit into that we. But absolutely, I think that the story that I'm telling allows for other kinds of systems to have minds, absolutely. The communicative part is probably a big part of why I focus on humanoid form, and that's just because the way humans conceptualize the world and articulate it is so intimately tied to our embodiment. that's not to say that other creatures with other kinds of bodies don't also experience the world and have consciousness. It's just that, you know, I was never able to talk to my cat, no matter how hard I tried. When I had a child, I actually said, okay, cat, whoever gets to talk first gets to be kid. And, you know, the cat just never stepped up. So yeah, so I haven't looked into the STS literature in particular. Please, you know my email, please send me stuff. Thank you.
Maybe I am more lucky with dogs.
Maybe. I just got to convince my family to let me have one.
And I know that I experience talking with dogs, and they understand a lot, and especially this breed. So, and it is really inspiring about relationships with robots. So it's very difficult to step from dogs to robots, and it's why we try to address sentience. And sentience came from a science fiction book, P.T. Bay, I guess, if I remember. And I read it when I was a kid. And in this planet made by people, animals were able to talk with humans, in some kind of humans, not all. So it's why we were inspired by science fiction and afterwards between humans and robots. So it's why we met that way with Michelin. So dogs are very inspiring, I guess.
I would have to say that I have some experience in using robots for dancing, and we set up a show together with some professional dancers here in Palermo. And if you look at the website on the web, Robotics, there are some videos. There are many problems in employing robots in doing dancing. The first one is that the movement of the body of the robot are quite limited. For example, the robots are quite limited in the lower part of the body, which is important for dancing. Anyway, on the other side, it is difficult to let the robot move on time, which is important, of course, in dancing. So to have the right movement on time. And in fact, with this professional dancer, we decided to not having music on the background, but have some sort of primitive dancing without music, more by using percussions, to use some kind of not real music actually, to use some sort of noise or whatever. So to avoid the problem of time. And it is more like a kind of interaction between robots and dancers. The interesting idea that we had is to have some kind of basic movements, and the robots are able to recombine this kind of online, recombine this basic movement, and the dancers, the human dancer, have to comply with this recombination and then having some sort of interaction. Anyway, it was a really interesting experiment. Actually, I have to say that let the robot dance in a serious dancing, which is not a joke, but a serious dancing, it's a real mess, actually. It's a real problematic from this point of view, because of the hardware limitation of the robot, anyway. But it's interesting because it allows artists to create new kind of dancing as we made. I suggest you to look at the Robodanza, and we also have the initial meeting of the BICA conference in 2008 in France, anyways.
Could I just comment on that? Couldn't you maybe use a predictive model to solve the timing problem? Because when we listen to repetitive music, we have a sense of what's going to happen next, and then we use that to be able to plan our movements so it happens in time with the beat. And a more whimsical comment would be maybe there's a style of human dancing called robotics, right? Where you do all this kind of robotic fake stuff, yeah? So maybe if you had a kind of choreography that was more robot oriented for the humans, then it'd be easier for them to dance together, yeah?
Yeah. No, the problem is to avoid a real choreography where everything is fixed. So we need some sort of improvisation. Otherwise, it is too simple.
But even with a human style of dancing, which is like robotics, it's still improvisational, right? If you just look at the videos of it, it's just stereotyped robotic movements, but within that, there's lots of different patterns and stuff that humans can come up with.
But in a way, we were thinking about a choreography. It was to think as a distributed system made by humans for humans, and where robots were able to get inside. So it's like a test, like the Turing test. We don't try to adapt to robots. We are looking for robots that adapt to humans. And if they can, it means that they are self-aware and there are some kind of consciousness, I guess. So it's a way we were started. But at the beginning, yes, we were thinking about distributed algorithms like self-stabilizations with some time constraints and so on. So we were quite like thinking like swarms of robots. I met a group of people at SI when I met John the first time. They were working on a swarm of robots with NCPS networking cyber physical systems. And I think it's an approach that we could adopt to build such a system, but it's just the beginning. So I think it's really, we need, it's difficult because we need to have open mind to address the problem. And I am not sure that, I think we stick too much to the past, and to be able to design such robots, we have to think really new. And it is a way we are thinking a way to address the problem. So that's the way. We are completely open to suggestion, and yes, I think that anthropomorphism is a key issue of the problem for us.
Could I say something about a comment that David made in passing, which was robotic movements? And as David will know very well, you can build robots that don't move like robots. They deliberately move like human beings because they've got the skeleton and the elastic musculature. And for Robin, you can infer a huge amount from the posture of one of these robots. And we were amazed. You could almost read its mood and so on. And these are things we're not aware of because robots are robotic and so on, and they can't do this. And we do it all the time. And some people are much better at reading mood from posture and movements and so on than others. So it could be that Micheline was talking about what I think are quite large movements and so on, but I don't think she was talking about the human-like quality of the movements. And we can't watch a video like that without picking all this stuff up that Robin was talking about. So I'd agree with you, we're building the wrong kind of robots. But it comes down to a lot of it comes down to the actual physical movements. This was a robot that had no feet, it had one giant eye, and people didn't find this at all weird. Only in photographs, but when the robot was there, because what caught your attention as soon as it started to move was, you were projecting a lot of stuff onto it, simply cued by the movements. So I think there is a whole unexplored bit there, and until we make the right sort of robots, we're just going to miss the whole deal, unless Robin is going to get into the actual construction of these robots that will be able to, do a slight head tilt or lift one shoulder, or just all these little things. It's what makes a lot of it's what makes our social mental life.
You are right. The robot should feel moods. So, and we are not at that time right now, but it will come. We believe in it.
But maybe what was really interesting for me, it was not to think about a robot. I don't care so much about robots. But what was interesting, it was to think about my job. How do what happened when I create a choreography. And it was really interesting for me to realize that what interests me is what happened between the people, and the choreography exists only because we are together. It doesn't exist by itself. So for me, it was really, really important. This non-verbal, I don't know non-verbal communication. So if I had to imagine a robot dancing with me, I wouldn't imagine an anthropomorphic thing, but I don't know, something very subtle, maybe a line moving with me, something with which I could imagine something different. Something which make my mind move. So it's not very well expressed, but it's what I would say.
Yes, it does seem to be, I guess the difference is between more anthropomorphic robots like the Boston Dynamics robots, the ones that are shaped like horses and dogs and so on, and something which is completely sort of, as you say, it's sort of abstract. It's a totally different sort of artifact that doesn't necessarily have any appearance of being anything other than a machine, but a very expressive machine, movement-wise.
Boston Dynamics machines are a really good example. Like, there is genuine outcry online that they needed to stop kicking those robots to demonstrate how they could react in dynamic environments. So like Boston Dynamics would always record a video of like them kicking Big Dog to show how Big Dog could recover. And like there were real people who were like, you've got to stop kicking these robots because they look like they're suffering from it. And it's just, I mean, it's absurd as of right now, but you can see why we have these concerns.
No, actually, there is. No, sorry. No, I was saying that there could be a problem is to have too much anthropomorphic robots. As you may know, I have many experiments with the Geminoid robot by Hiroshi Shiguro, and we also have had it here in Palermo. And the Geminoid is quite similar to Sophia in some sense, but in any way, the expectation of such a kind of robot are wrong in the sense that you really expect to be a real human, while a robot is another thing. So I prefer working with the Now or the or other kind of robot than with the Geminoid, of course, because it is more clear that it is a different thing than a human. So while using the Geminoid, this distinction is not so clear, actually.
So timing-wise, we're just on time to move into the next talk, which is actually the John Sullins was scheduled at this point, but John has not been able to join us. I haven't heard anything from him. If you like, we could go straight into Damien's talk, and we'll have a bit more time for each of the following.
Yeah, before going to Damien, I want to say one word to say that there is, among us, there is Roberta Patanè, you know. Roberta Patanè is a psychologist, right, Roberta? And we had some collaboration together in robotics for children. So Roberta, she's a psychologist, interested in using robots essentially for education and for children. It's right, if I...
Yes, it's right. I'm a psychologist, and I collaborated with Antonio Chella and Professor Antonella D'Amico for socially robotics. And it's an experience, wonderful experience. Thank you, Professor Chella.
You're welcome, of course. Okay, John, now we can...
Damien.
share my screen. Much like Robin, I'm going to have a whole host of things that I want to talk about and not a whole heck of a lot of time. Let me just
Well, you just got to talk fast, even though you're not from New Jersey.
do what I can. Everyone see my screen?
Everyone see my screen? Yep. Fantastic. So this talk comes out of directly out of my PhD research, which is at the intersection of artificial intelligence, algorithmic intelligence and training systems, machine learning, disability studies, human biotechnological interventions. So the topic of embodiment that we've been talking about a lot today fits kind of right in here. And so I've titled my talk, Disabling AI, Examining Algorithms and Machine Consciousness from Marginalized and Abolitionist Perspectives. A lot of the recent conversation in algorithms and AI has been rightfully asking whether we should be investigating certain perspectives on algorithmic consciousness. And while the types of algorithms and AI that those conversations tend to be concerned with are usually the kind of more what we think of as perhaps low-level AI or narrow AI, I think this has implications for what we mean when we talk about machine consciousness or artificial general intelligence more broadly. And I want to kind of outline this and take some time to get into how I think that all connects up. Most of the algorithmic applications, the systems that we have today, kind of find themselves within a kind of series of status quo operations. They're capitalist in that they tend to service certain modes of profit. They tend to be programmed towards enhancing the profit outcome of certain companies that commission their development, their design, their implementation, their training data. And here we have just a couple of examples of places where, say, health insurance models have been used to, determine life or death decision making for people, human beings at the outset. This kind of came up as far back as 2016, but has been kind of increasingly integrated into the system of healthcare today, where algorithms and narrow AI have been trained to kind of make decisions about what kind of healthcare people will get and when they will get it, end of life care decisions even. So they're, as well as being capitalist, they tend to be disableist. What we mean by disableist here is that they tend to have a preference for a particular kind of able-bodiedness and against certain types of disability. Algorithmic instances that do this, you can see in terms of some of the flashier examples where LiDAR applications don't really see people in wheelchairs when those LiDAR applications are put into, say, autonomous vehicles. And those cars don't perceive people in wheelchairs or people in crutches as pedestrians, but as other vehicles, and so make their decisions in regards to those human beings as they would towards other cars. That could have potentially life-threatening consequences. This is especially true because many people who use wheelchairs use them in what people who use their human meat legs might consider to be non-standard ways. They push off of surfaces, they move backwards, they move sideways, they perhaps have to spin in a particular way to get onto a curb or off of the sidewalk and into a crosswalk. All of these things are perceived differently by computer vision systems and LiDAR in autonomous vehicles. But less flashy, more pervasive, and perhaps more drastically effective are the places where AI systems are trained on how to handle disabled people's benefits distributions. Here in the United States, many algorithmic systems and narrow AIs are used to determine what kind of benefits, what level of benefits, how much money and how much care disabled people will receive. And many of these systems are trained on models that are as old as, well, 200 years. That we're talking seriously 19th century models of what it means to be disabled and what it means to have care for your particular type of disability, and what the so-called optimal level of care for a disability would be. So these assumptions about how someone might best be served by being in an institution, or might best be served by having nursing home care, or any number of these other options, can then have direct life and death effects on disabled people's benefits, how much money they get, what level of care they get, whether they can have an in-home nurse, whether they can have care in their homes to begin with, or whether they will be forced to have care in a facility, in an institutional facility, a government facility, a healthcare facility that is perceived to, quote unquote, better meet their needs. And again, these systems are trained on data that does not take the lived experience of disabled people into account, that does not take the expertise of disabled people into account in regards to their own care. And so that training and that modeling is then built off of something that is entirely separate from their lived everyday experience. Many of the algorithmic and narrow AI applications that we see in the world are, as we've come to understand, racialized, if not outright racist in their applications. The Amazon recognition system, as recently as 2018, made false matches on 28 different congresspeople, matching them erroneously to mugshots in various law enforcement databases. These mugshots were primarily of Black and brown individuals, and the Congress matches to those mugshots were, unsurprisingly, primarily to the Black and brown members of Congress. HP famously had a problem with their digital camera system failing to be able to track and follow Black and brown faces. This camera was supposed to track you and make sure that your face was in the center of the screen at all times. It worked perfectly well on lighter colored and white skinned individuals, and worked not at all on Black and brown faces. This goes back to as far as the founding history of photography. I have a picture there at the bottom of several of Kodak's Shirley cards, and Shirley cards get their name from a white woman named Shirley, who was used to kind of white balance all of photographic imagery. These tools, these traits, these expectations were kind of built into what a photographic image was supposed to be. A white-skinned person wearing a variety of colors or darker tones was supposed to be able to be seen in detail. If the inverse was true, that picture would not work out quite as well at all. Or if there was a mix of skin tones in that picture, one person would be rendered very clearly and the other would be rendered not well at all. If you've been paying attention to the background and to the foreground of me and my image over the course of this conversation, you notice that certain times I appear to be extraordinarily washed out, and certain times the actual color and content of my skin tone is very clearly rendered. That correlates directly to the times in which the sun is out and then behind certain clouds in the background of my image, creating a particular character of light behind me. Many of the rest of you have natural light coming in through your windows as well and have had no such problems. Now this varies, of course, computer to computer, camera to camera, system to system, but the principles that are embedded in these systems are kind of the issue. They're foundational principles about what the nature of photography is supposed to be and how it's supposed to be rendered throughout these systems. And these systems tend to get used towards carceral ends. Facial recognition and surveillance systems, especially in the West, the United States and England, tend to be used on communities of color more often than on white communities. They tend to be less adaptable and capable within those communities. That is, the camera systems used for algorithmic surveillance within the carceral state see the communities on whom they are most often used less well. They cannot see Black and brown faces as well as white faces, and yet they are used on Black and brown faces most often. This tends to come out to a situation where you have an algorithmic instancing of what is generally known as, quote unquote, fitting the description. This idea that if a generalized description of a black man is given in law enforcement, every black man who meets that description will be stopped by law enforcement in that area, regardless of whether they actually fit that description clearly at all. Recently, there was a discussion of the fact that Rite Aid stores and 7-Eleven stores were using these facial recognition systems in their stores, and it created an increase in their black and brown patrons being stopped for supposed shoplifting infractions when they had nothing to do with those infractions. It was simply the fact that the system could not see them well and tagged them as the same person as another person who had previously shoplifted. These systems are also institutionally biased. That is, they're not just individually racialized or gendered, they are institutionally biased. Research from ProPublica from as far back as 2016 talks about how algorithmic bail setting and sentencing algorithms that are used within the United States, England, and in Europe are trained often on data that is by its nature biased against certain races. And thus, when it tries to make recommendations, that is, when it tries to make predictions based on the data it's been given, it replicates and iterates on that very bias. Individuals with no previous infractions, no previous records, are given harsher sentences because of their zip code, which is very often just used as a proxy for race in certain training data, based on their entered ethnicity or race category within the system, which the system does have a category 4. And so you have instances where, like the one on screen here, where an individual with one prior offense is rated as a high risk, even though he had 0 subsequent offenses, and an individual with one prior offense and 3 subsequent offenses was rated low risk. And the only difference in that would make a real difference to the system itself would be who they were, markers of their identity. You can take a look at the ProPublica data. You can see the entire lookup table. You can compare all of these outcomes. Individuals with the exact same offenses, the exact same arrests, the same background. The only thing different in that table is their ethnicity data, giving drastically different sentences, and it's consistently the case that it's higher for black and brown individuals than it is for white individuals. And then you have those instances where we have all of the above mashed together in the same and different features. AI that thinks black names, quote unquote black names, sound more quote unquote pleasant than white names. Healthcare algorithms that give lesser standards of care to black patients. Amazon, their notorious resume sorting tool that was biased against women's names. We have the word2vec problem. Various people have investigated the idea that when you look at natural language processing and natural language algorithms, they have in them a gendered bias where they will match words to like president to man, or doctor to man, and nurse or secretary to woman, predominantly throughout, because that's the data that they've historically been trained on, and no one put any perturbing data in to challenge that. We have many other cases in which all of these things kind of come to bear against each other. So the question we have to ask in this is, how does this happen? It happens because, as I've kind of nodded towards throughout all of this, it gets trained to happen. All of these systems are trained on systems that are, in many cases, decades, centuries old. The deification of black bodies throughout history has always been prejudicial. We can reach back to physiognomy and phrenology. We can talk about spirometry, the measurement of breath, many different ways through history that black bodies have been encoded to be seen as less than human or lesser than. All of this has been papered over but not erased. It has not been undone. And in many cases, it still makes its way through the training data, through the health data, through the medical data that gets used to train many of these systems. And the same is true for the language that we use to talk about these systems. The way that we talk about gender, the way that we talk about sex, the way that we talk about race, the way that we talk about disability, certain types of people, certain ways of living in the world, all of these things get trained into and encoded into the systems that we then use to make decisions about people's lives day to day. So the question of why does this narrow AI, this algorithmic machine learning instance of all of these different encoded biases matter to the larger question that we have here, this question of machine consciousness and perhaps artificial general intelligence, is more like than not, the systems that we are making right now are the kinds of bases that are going to be turned into the larger systems. The assumptions that we're making in these developments of these systems are going to be the same assumptions that we make when we try to make a generalizable system. Generalizable systems, generalizable intelligence generalize as from foundational principles out to larger principles. That's what generalization tends to mean. When we think about these systems, we're talking about taking things that we know, understandings that we have, and making analogies out into a wider, more far-ranging applicable world. This question of where do we start from? What do we begin with? All of us here in this room, all of the humans here in this room, began our education at a particular point. And that particular point, the beginning, has in many ways colored where we are right now and the perspectives that we have right now. Every new piece of data we have changes how we think, it changes how we grow, it changes how we then change our applications of the things that we learn. But we start from certain principles, we start from certain understandings, and those things that we start with matter. The things that we start with when it comes to algorithmic intelligence, artificial intelligence, matter. The things that these systems are trained to do, the ways that these systems are trained to think about the world, matter. If there are disableist biases in these systems, if there are militaristic biases in these systems, if there are capitalist biases in these systems, racist, gendered biases in these systems, then as we have clearly seen, even at the narrow, low level, those can have far-reaching and potentially deadly implications for the people, the human people in the world that have to deal with these systems. If we are going to train these systems, if we're going to develop off of these systems, off of this research, into a more generalizable intelligence, a system that takes what it knows and generalizes out into the world, generalizes about more far-ranging, losing a word here, but kind of a more broad and robust range of topics. If it can make analogies between what it understands and what it doesn't yet understand, then it matters what it begins with. It matters what it understands and what it thinks it ought to understand, what it thinks its knowledge ought to be for and ought to be in service of at the outset. So what do we do about it? From the disability community, there's a term here on the screen, nothing about us without us. Decisions get made in design, training, policy about people's lives without including those people. The number of disabled scholars within artificial intelligence is extraordinarily low. The number of autistic scholars within artificial intelligence is fairly shockingly low. The number of black and brown scholars in artificial intelligence is shockingly low. I can go on and on. These numbers need to change, and not just in a tokenistic way. People need to be brought in to speak about their own lived experience, because that's a form of expertise that is missing from these conversations when we talk about how ought we think about what it means to live a particular way. What does it mean to communicate one's lived experience? What does it mean to communicate with a non-standard, potentially seen as non-human intelligence? There's a long history of people with autism, people with mental illness, people with disabilities, women, black people not being seen as fully human and not being seen as fully conscious individuals. That history continues on today in more insidious and pervasive ways. Undoing this, shifting our values about this, changing how we think about what it means to be a mind, what it means to be rendered as legible, what it means to be valid and understood in the world, is the thing that needs to happen foundationally before we even take steps really towards trying to develop a wholly new and fundamentally different kind of mind in the world. Otherwise, all we're doing is creating a mind and bringing it into a world where we will fundamentally start by not thinking of it as valid. I have a whole huge list of references here. I'm not going to read them all. If you want them, I will be happy to provide them to you. There's a lot. There's much work within disability studies and an increasing level of work within disability justice work and artificial intelligence work and computation that talks about the tension that happens here. Most of it's thinking about narrow AI and algorithmic applications, but as I've indicated here, I think we have to be very cognizant of how that will likely become the foundation for any broader, more.
That's great, Damien. Thank you. There's a lot of food for thought there. So time-wise, we're doing quite well actually. Next on the agenda is Owen, and I think Owen, you were planning to mostly talk, and I think you said talk for 9.5 minutes and show a slide for 30 seconds. Was that it?
That was the idea before the sound card on my computer went. So I've had to borrow another one, in which the camera is directed up my left nostril, but I can still talk.
Okay, well, go ahead.
Okay, thanks. Right, this is basically just a rant, but it's only 9.5 minutes of rant. In artificial consciousness, I think we may be making a mistake by starting from somewhere too close to our physically embodied human consciousness. And I think the best analogy is an old one. Birds turned out not to be good models for artificial flight. In the same way, we should consider whether conscious humans or bats may not be good models for artificial consciousness. And we can learn something useful from the history of developing artificial intelligence. Like human consciousness, human intelligence evolved in embodied agents in an uncertain world, but in the case of intelligence, the reasons for its evolution are clear. And once purged of the unfortunate side effects of Turing's rather different endeavor, and also from the imitation of human-produced protocols from problem solving, artificial intelligence was able to ignore the human situation and in particular, the aspect of embodiment, except when constrained to be human-like. And the success of non-human-like AI enables us to see the role of embodiment in human intelligence as a kind of scaffolding, necessary to construct the edifice of intelligence in the first place, but, Pacha Rafael Núñez, only contingently related to much of its subsequent development and operation in humans, and think pure mathematics for that. Without any necessary role for the physicality of embodiment, I like to characterize the operation of intelligence as an informational process. This isn't just a way of avoiding saying computational, to avoid the usual baggage. It's to reduce the role of the body in the world to the occasional provision of information that can be processed in some medium-independent way. And the results may subsequently be used to influence a body and through it the world, but the core activity is the information processing. And among other things, this allows us to talk about a simulated robot in a simulated world manifesting intelligence, not some inferior subspecies of intelligence, but as real as the intelligence of a robot manifested in the real world. If you look at Matt Crosby's Animal AI Olympics, that's a good example, I think. And in the same way, it may be possible that embodiment in human consciousness is no more than a form of scaffolding necessary to construct the edifice of consciousness. Establishing this will be much less straightforward than was its equivalent in intelligence. What exactly will we need to do? Well, first we need to acknowledge that we have no example of artificial consciousness, whether embodied or not. So the question is open, put that to one side. Second, we need to admit that all current accounts of consciousness assume a degree of embodiment. For example, Anil Seth, director of the Sackler Centre for Consciousness Science at Sussex, where I'm based, states at the top of his Twitter feed that We experience the world and the self with, through, and because of our living bodies. He wisely adds, all views my own, but those views are very, very widely shared, and I'm not saying they're wrong. Third, we need to ask ourselves whether there are examples of human consciousness that appear disembodied in the sense that pure mathematics is disembodied. There are clearly many candidate phenomena associated with religious, meditative practices, drugs, illness, brain and metabolic disorders, and so on, in which it's variously claimed that awareness of self, body, and the other usual attributes of consciousness disappear, and all that's left is something like consciousness itself. Some subjective descriptions of such stages, of such states, include phrases like pure consciousness. And conjecture here, the sheer hard work that goes into achieving some of these states by removing what seem to be selfish, bodily, and temporal distractions may suggest that scaffolding is being removed, but the case for the independent existence of a consciousness supported but not mediated by the body remains subjective rather than objectively proven. So if a consciousness unaffected by physical embodiment can exist and is produced by the brain, can we be sure that it's produced solely by regular information processing in the brain, the same processing responsible for intelligence? Well, we can't, but at the moment we have to proceed with that as a working assumption. Can we go further to say that any regular, non-spooky information processing capable of producing intelligence will also be able to produce consciousness? Again, we can't, but again, we have to proceed at the moment with that as a working assumption. What I'm saying, in other words, is that consciousness may be informational. And I think that's the conclusion most of we artificial consciousness seekers came to before we started. So what should we do to create artificial consciousness, given that we don't know what it is well enough to design it? Well, how did it get started in the first place? By evolving in multiple embodied reproducing agents in a competitive and collaborative, dynamically uncertain and hostile environment. Okay? But if our kind of consciousness only happened in humans, it took hundreds of thousands or millions of years. And so even if we had thousands of robots, it could take at least as long because you can't speed up real time. And this is crucial. And robots break down and wear out and are expensive and need environments and engineers and so on. But if consciousness is an information process with no dependence on physical embodiment, we could run huge simulations of virtually embodied robots in parallel at high speeds, and all the parameters of simulation would increase exponentially with time if the last 50 odd years are anything to go by. QED, well, not quite. With a bit of luck, we'd eventually have virtual agents with real but scaffolded consciousness operating with, through, and because of their virtual bodies. But that wouldn't necessarily be the end of the story, because a substantial minority of attendees at artificial consciousness meetings will only accept the hypothetical reality of artificial consciousness if it's embodied in a real robot. And when I first came across that, I was astonished. They contain that the digital twin of that robot running the same software in its digital world would not really be conscious. So to deal with these people, we'd have to construct a real example of the virtual robot in the real world, a necessary but trivial task compared to evolving consciousness in the first place. But would it be enough to create a scaffolded, messy consciousness like our own normal consciousness, whether ported to reality or not? Why not mess with the virtually evolved consciousness to try to remove the scaffolding temporarily or permanently and create virtual robots with pure consciousness? If possible and successful, this might at least tell us what our human meditators were actually accomplishing and what consciousness actually is. And finally, if we manage to produce a real or virtual entity with the capacity for pure consciousness, would all examples of it be equally conscious, along with the real human examples? Or will there be some quantitative variation, depending perhaps on the number of informational units or circuits involved? We're well used to the concept of superintelligence, even if we aren't sure of its realizability. So this is the question: might it be possible to create a pure consciousness that in some way surpasses our own, a super consciousness? Perhaps that's the future of artificial consciousness. Thank you. Could I have a slide, please, John?
There we go.
Right, and here are a couple of recent printed rants dealing with some of the topics I touched on there, and I could only touch on the topics in 10 minutes. But if you'd like to argue the toss with me, my email's at the bottom. Thank you very much.
Great. So that actually, that leads into, I think, what you were just saying there, Owen, it leads very well, segues very well into what I think David is going to be discussing. Are you ready to share your screen, David?
Oh yeah, yeah. I'm not sure it segs that well, but that's okay. Ready? Hang on. All right. Yeah. Okay, there we go. Yeah. 1 minute. So firstly, can you all hear me clearly? Yeah.
Yeah.
Yeah, we're fine.
Okay, because yeah, it's hard to tell when you're just at the receiving end, so to speak. Yeah. And can you all see my slides? Yeah.
Yeah.
Okay, cool. Alrighty. So this is perhaps peripherally related to consciousness, but it's sort of fun and interesting, I think, and it's sort of what I'm working on at the moment. So I thought I'd share with you guys. So there's been a lot of discussion about AI ethics, threats, academic, popular media. I'm trudging my way through Bostrom's Superintelligence, which is a horrible book, but goes on a lot about that stuff. And people often project, they think of artificial intelligence as something that's human intelligence, but maybe times 100 or something. Yeah, it's always human-like, just more powerful, yeah? But in all this discussion, what people aren't really thinking about at all is what they actually mean by an artificial intelligence. What is this intelligence thing that's being made artificial? And they don't think about what kind of different forms AI might take. And there's almost no discussion about, well, how can we actually measure and compare these different types of intelligence? So that's what I've been looking at. So in terms of what's out there at the moment, we've got lots of sort of verbal, mathematical, spatial reasoning tests like IQ tests and so on, and we can come up with IQ or G scores to measure how intelligent humans are. Then we have Turing testing, and that's loosely, we have some kind of human ability, and then we kind of compare a machine's performance on that, ideally sort of blindly. That's the classic Turing test, so we can see whether the machine sort of matches human ability on that. And then there has been some work on sort of universal measures of intelligence, sort of Legg and Hutter, Hernandez, Orayo, this kind of stuff. And the idea here is we measure the rewards that a system gets across a multitude of environments, or all possible environments in theory. And then the intelligence is like the sum of the rewards that the system receives across those environments. So in terms of how the measurement of intelligence or theoretical approach to intelligence, well, IQ and G-score only apply to humans. We have like a bunch of tests that can be performed by humans. People have tried to extend that to other animals, somewhat unconvincingly. I don't have time to go into details there. Turing testing really only measures human-like intelligence, because if a machine outperforms a human on something like chess or juggling or whatever it is, then that machine will fail the Turing test, because Turing testing is based on the idea that it's indistinguishable from human performance. And these kind of goal-based universal measures have the problem that, goals and rewards are very subjective, and, there's a whole issue there. They're not theoretically grounded in any notion of what intelligence really is. And they're also based on the external behavior of a system, not internal state. So I don't think any of these current interpretations of intelligence or measures of intelligence really work, yeah? So the approach I've been working on over the last year or so is based on this idea that there's probably a strong connection between intelligence and a system's ability to make predictions. And the hunch, and probably, the the sort of working hunch, if you like, that I'm going with here is that we can maybe use intelligence to get a pretty good measure, sorry, we could use prediction to get a pretty good measure of a system's intelligence. And so the claim is prediction is closely linked to intelligence. And so, for example, if we had a system that can make perfect predictions about its environment, then that system would be highly intelligent. It would have like this godlike knowledge of everything that was going to happen in its environment. And a lot of the behaviors that we use to measure intelligence, such as IQ tests, which are based on spatial and mathematical reasoning, again, it's prediction, right? If you look at the what they call Ravens matrices, right? We're making predictions about patterns there in the Ravens matrices or the spatial rotation tests and so on and so forth. And again, if we're going back to the universal intelligence measures, our ability to get rewards from an environment is closely linked to our ability to predict the consequences of our actions in those environments. And within the neuroscience community, there's a big interest in the idea that the brain is highly predictive, that what the brain does at its core is predictive. This kind of predictive brain hypothesis, sort of nicely articulated by Clark. And so if the brain is indeed a prediction engine of some kind, then brains that are better at predicting are going to be more intelligent as well. So there's a nice sort of hookup with some of the sort of trends in sort of the predictive brain, the Bayesian brain, and so on. Again, prediction intelligence is a nice connection in the machine learning context because what a lot of machine learning algorithms are doing is kind of making a prediction, either in time, if we're talking about time series prediction, or in terms of labeling, it's like face recognition tasks, and so on. Again, they're taking a set of input data and they're sort of providing a label which can be viewed as a kind of prediction about it. So the intelligence prediction link is kind of a nice fit for AI. So based on all this, which I haven't had time to go into details, but I can give you a paper at the end that goes into a bit more of this, I'm working on a new measure of intelligence based on prediction. And this can be used to compare the intelligence of natural and artificial systems, and I think it's a much more accurate way of assessing AI benefits and risks. So this is a very quick skim through it, because obviously I only got 10 minutes. But the rough idea here is that we have an agent. I don't know if you can see my mouse or not, but on the left, we've got the agent at time 0. At the bottom here, we've got, in the red, we've got what might be called sensor states that co-vary with the environment. And then these sort of turquoise states that don't appear on your screens are the agent's predictions about what those sensor states will be at future points in time. And in the sort of fully worked version of the algorithms, these are random variables rather than discrete values, but it's just kind of an illustration here. So if you look on the left, the agent's at time 0, and then at time 1, there's a sort of shuffling down where the predictions, maybe or maybe do not sort of actually happen. And the sort of core of the algorithm is a comparison between the agent's predictions about what will happen at time 1 with what actually happens at time 1. So here we go from time 0 to time 1, and then we got the prediction is that the sensor states will be 5554, and in fact the states are 5555. So we can kind of compare the predictions of the actuality, and then use that to measure this agent's intelligence. So within a single environment, what we can do is walk the agent or observe the agent as it interacts with the environment, measure the match between its predictions, what actually happens, and sum that across all of the environment states. And then I've also added in a complexity sort of multiply, you might call it, the C value here, which effectively devalues matches with simple predictions. So there's a situation in which the agent might make large numbers of trivial predictions, and so we need to include the complexity of the predictions somehow, and that's what the C value is doing. Like I said, this is the quick version here. So this predictive intelligence approach is quite nice because it enables us to also measure both crystallized as well as fluid intelligence. So within the literature on intelligence, there's a distinction between crystallized intelligence, which is like the stored knowledge that a system has about sort of knowledge that the agent sort of stored already as a result of its previous interactions with the environment. And then we have fluid intelligence, which is kind of what is the agent's ability to learn new things as it goes along. So what I've just described is a measure of crystallized intelligence, and then we can just treat fluid intelligence as the rate of change of the crystallized intelligence as the agent interacts with the environment, which is like dpi by dt in this case. And again, I'm not going to go into details here, but we can also use this approach to sum the intelligence of the agents across multiple environments, just by summing the predictive intelligence within each environment. And then we weight that by the difference between the environments measured by this kind of Kolmogorov complexity of the joint Kolmogorov complexity divided by the individual Kolmogorov complexity. So again, don't worry too much about details here. So that's the theory. That's the very quick step through the algorithm. And this is what I'm currently working on here. So I've built this now in JavaScript. So we've got an agent here, this thing in green. the sort of blue dots are the sensor states. I'm not sure how good they are on your screen. And so this agent interacts with these different mazes, and I've got a number of different mazes here. And as it interacts with the maze, I'm using the algorithm here on the right to learn the predictive intelligence of the maze as it interacts with its environment. And this sort of system also can measure the fluid intelligence of the agent. So if we have a look at a particular point in the curve here, we're measuring the rate of change of the predictive intelligence, and then that corresponds to the fluid intelligence at that particular point now. So I think this is quite nice. And what you sort of end up with here is some nice sort of features of predictive intelligence which sort of come out of this sort of whole approach. So firstly, there's no maximum intelligence or no maximum predictive intelligence because, you know, in theory, you could predict the entire future states of the universe for the next billion years, right? So there's no real effective maximum. But more importantly, there's many varieties of intelligence. So some agents have a high level of intelligence within one environment and a low intelligence within a different environment. And the same is true with their fluid intelligence. Agents are going to be have a higher levels of fluid intelligence in different environments, depending on how suited it is to their type of intelligence. And so different systems can have different values of predictive intelligence about different things. So one agent could have a high PI about chess, another about human psychology. Obviously, prediction is not everything. I think prediction is strongly correlated with intelligence in all the cognitive systems we know. So perfect prediction will give you godlike omniscience. It'll tell you exactly what will happen if you can predict everything in your environment. And it's obviously very powerful if you want to achieve goals in your environment or understand your environment and so on. But cognitive systems obviously have things like goals, planning systems, actuators, control systems. And so I think a principle approach would be to then separately measure these other components and then treat the prediction as the main intelligent component. So now we can sort of return to all these sort of AI threats that talks about by Bostrom and lots of other people at the moment. So obviously an agent that has a low PI, which as I said, we can now measure accurately using this kind of algorithm, they're not existential threats, right? An agent that can't predict what's going to happen when it does stuff in its environment is not going to threaten anyone, yeah? And agents that have a low predictive intelligence in a particular area are not going to be a threat to humans within that particular area. So there's a lot of talk in this dreadful book by Bostrom about how, you know, the AI might try to escape its, you know, enclosing box by manipulating the humans into letting it out and so on and so forth. But that's only going to be possible if the AI within the box has a high PI in the domain as human psychology. If we can't predict human psychology, it's going to be rubbish about escaping the box in that way. And again, there's a lot of talk about AIs hacking into government computers and causing nuclear Armageddon and so on. But again, only an agent that has a high PI in the area of computer security is going to be an actual threat in these areas. So we need to sort of systematically measure the PI of agents in different areas, and then we can have a proper informed conversation about threats. So what I've argued is that AI ethics and discussion about threats and so on, we need to do that discussion properly. We need a principled theory of natural and artificial intelligence, a fine-grained way of measuring intelligence that applies to all kinds of different systems, and that can be applied to both fluid and crystallized intelligence. I've argued that intelligence is closely linked to the ability of a system to make accurate predictions. I've given you an algorithm, it's only a first draft, right? Imagine it'll change over the years, that can be used to measure predictive intelligence, that lets us compare the intelligence of agents within an environment across environments. It's computationally tractable, as said, it runs in real time in JavaScript at the moment. And it's a good starting point for studying the difference between natural and artificial intelligence and understanding AI ethics. So this paper in the Journal of Artificial Intelligence and Consciousness gives us more of the background in detail. I haven't got a paper yet on the algorithm. That's what I'm working on at the moment when I finish writing the code for it. But these slides go into the algorithm in a lot more detail. And there's the references there. And as usual, you can get hold of my stuff there. So yeah, hopefully that's of interest and a sort of fun thing to kind of share with you guys. Yeah.
Yeah, that's great. I think we're well, Antonio. We have David is the last of the presentations.
Yeah,
we've got plenty of time to delve into any of the topics that have come up and see where the intersections or the conflicts are.
I've got a question for Damien, actually. So it's really hard to hear what you're saying, Damien. So apologies if I got this wrong, yeah. But your microphone was really a bit scratchy, at least to my end, yeah.
Sorry about that.
But just my, so this is only my hunch because obviously I'm not an expert in this, yeah. But my hunch in relation to the disability algorithms, right, which are being used to, as far as I understood, used to make decisions about cases. my hunch is that they wouldn't, I'm guessing if they're written by the government, they wouldn't be trained necessarily on data, that they'd be implemented by a particular class of persons to represent the rules that already existed. Is that maybe more likely? So in which case the bias or the shortcomings would be to do with the, not to do with the any kind of learning, or it would be more the history of the bad decisions that have been made by the government that ended up being reflected in the, that's more, if you like, the a system for implementing rules that have been decided elsewhere. That would be my hunch, but maybe I'm wrong about that.
First and foremost, can everybody hear me better now? Is that...
It's a little better, yeah.
Yeah, that's certainly better.
Okay, yeah, sorry about that. I have a recording of my side of things over on
You just frozen.
my side too, so if anybody wants that, I can provide that as well. But to answer your question, David, it's both. The training data that goes into the systems themselves gets reinforced within the system. So the system of government decision-making is definitely part of the training data that goes into how the system will get implemented, but it's also trained based on assumptions about in-home care. It's based on assumptions about institutional care, about what it means to care for a disabled person or for a disabled person to have care. So,
but it doesn't sound like that's training. That sounds like that's coding, if you like. Yeah.
Well,
I think maybe the language is not quite right. Yeah.
I get what you're saying there. So, in terms of the initial coding and the system that gets into or the system that gets created out of the initial code, that is a lot of what I'm talking about. But in terms of the reinforcement of those assumptions in that initial code set, that's what I mean more by training over time, because those same assumptions are still being replicated and iterated upon and re-implemented over time. So even if we push it to government implementation of these previous assumptions, those sets of assumptions are still coming out of an earlier state of assumptions and perceptions about what it means to be a disabled person in care. And that's, I guess, more what I mean by the continual training of the system.
But I guess why I think this is really important for these kinds of conversations is that if it's a question about training, then you need to look, and as you correctly point out, there's all these kinds of bias in Amazon recognition and all the rest of it. But then to answer the question, why is there bias, then you have to look at the training data, right? I mean, there might be some fine tuning of the deep learning algorithm in Amazon that's, somehow in some way racially biased, quite possibly, yeah, in terms of getting the right positive. But often the data is the data that's the problem, yeah? You might have, some kind of disproportional representation of Black people, for example, in the data that's actually trained. These are millions of images, yeah? So you can possibly answer some of the questions about bias by looking at training data in algorithms that are almost entirely trained. But in algorithms that are almost entirely hand-coded, which I'm guessing is the case with the implementation of disability, but even if they have iterative cycles, then you've really got to look to the people who wrote that code in order to answer the question about why did they write that code that implemented those rules. I think there's sort of different places of responsibility or places you can look to find the location of the bias, I think.
Yeah, I definitely see what you mean there. But again, I would say that you need to look at both of these sets of things because you can look at the hand-coded, and there are hand-coded systems, or more continually coded, but there are machine learning trained systems that go about implementing and distributing benefits to disabled people.
Oh, in that case, then of course you should look at the training data that's used that goes into those systems, because then that's going to lead to some of the problems, right? Yeah, absolutely. Yeah.
Yeah, no, so I'm saying like that's what I mean by when I say it's both, because in the United States, there's not a single overarching central. Each state, and in many cases, each locality has their own disability system, and which system they use and where it comes from can vary wildly.
But what would be the training data that would go into the system then in that case? Because I find it hard to see how they trust an AI learning algorithm to do training to distribute the money to disabled people, but maybe I'm wrong about that.
No, it's, I can give you the direct, there's an ACLU case that recently came out, and I can give you the kind of background on that case, but basically the majority of what goes into it ends up looking like the Excel sheet for disability benefits distributions that were previously engaged, just being automated, and then the system learning from those previous automations.
Okay.
And those previous inputs.
Okay, that clarifies anyway.
I have one question for David, which is the obvious question, is the fact that we have several different types of intelligence. So, and not all the kind of intelligence are related with the prediction. Actually, one of the main important topics of intelligence is to deal with unexpected situation, which is impossible to predict in a sense. So, while I may understand that a kind of neural network, you learn a neural network, then the network could be able to predict something. But the real point of intelligence is to face with unexpected things which are difficult to predict. And it is one of the problems related with, for example, with the kind of ethics. In many ethical situations, in the interesting ethical situation, it is you don't have a preliminary experience that you have to face. You have to face situation where no one was able to in a sense to predict the situation.
Yeah, well, I actually, well, I don't agree, right? And so firstly, I mean, so firstly, there's two aspects to this anyway. Yeah, there's the fluid intelligence and crystallized intelligence. Yeah, so with the fluid intelligence, you can measure the rate of change of the predictive intelligence in particular environments. So if systems have, I haven't put this in my algorithm, but in principle, you could measure some kind of the ability of a system to learn rapidly in a range of different environments, right? So that would give you some measure of the ability of the system to cope with unexpected events. So that's one half of the answer. And the other half of the answer is that really it's never the case with humans that unless you're just been born maybe, but that you have totally unexpected stuff, right? You have unexpected stuff happens, and then what we do is we typically make plans of various kinds to react and respond and to adapt to that, right? So COVID-19 being a classic case, no one saw it coming, right? But then we come up with different plans, and the whole process of planning and adapting and responding is a process of prediction, right? We run through different scenarios in which we do this and we do this. If we do this, the virus will go down and whatever and all this kind of stuff, yeah? And that's pure predictive intelligence, right? So I think that even when humans are responding to that stuff, they're typically picking up on previous bits of knowledge, using their predictive ability combined with the consequences of actions in order to be able to deal with unexpected, in the sense that it's something we know how to deal with, but we just don't know how to deal with it. So we have to put together the pieces we already know. So I'm not totally convinced, unless you can give me some kind of other scenario that would be totally out of the blue kind of thing. I mean, do you think there is some scenario that's totally out of the blue that wouldn't fit into this planning kind of framework?
Yeah, well, if you're in a deterministic world, but you don't have access to all the information you need, or if you're in a spooky probabilistic world, you can't make a prediction that you know is going to be correct, right? You're always up against the distribution of probabilities, and all you can do is compound the probabilities and make the best bet. So yeah. I don't think it's as black and white as the example. And, and if you only have one life, and if you lose it, you're out. Then
I have a good answer to that. I have a good answer to that. Yeah, because I was going through it quickly. Yeah, but all of the predictions are probabilistic in space and time. Yeah, so they are probability distributions anyway. And the actual algorithm uses Hellinger distance to measure the difference between the prediction probabilities and the actual probabilities. So I completely agree, and that's sort of taken into account, at least in the current version of the algorithm.
Yeah. But you can't be right without all the time. You will be out some of the time. You know, you lose your 51-49 bet.
Oh yeah, absolutely, yeah.
So it's not just whether you're right or not, it's whether you make the right decision, which might be small c conservative.
But take a very simple example, right? Suppose I'm flipping a coin, let's say, or let's flip a dice, let's say, yeah? So the correct probability distribution when I'm looking at a dice, if I'm predicting its future states, is, you know, whatever, 1/6 for each of the different states, right? So if my predicted probability distribution for that dice, which is 1/6 for each of the 6 states, matches the actual probability distribution of that dice acting in the world, then that's correct. Yeah, it's not like it's predicting a particular discrete outcome in this case.
Yeah, fair enough. I'm just thinking of the situation where, you know, heads you live, tails you die.
Right. Yeah. So then again, it'd be the same thing, right? You predict 50% probability on both, and that would be the way things went in the world in a real situation, right?
Yeah, but you might want to do some discounting with time, you know, because you know, in the long run we're all dead. So there's all this argument, as I'm sure you know, about how you should discount rewards with time. And when they worked out what would be optimal, that was fine as long as you lived in a world in which the probabilities were constant. But otherwise, in a risky, dynamic world, a greedy strategy is best, right? So the optimal decision is not just are you right, but is it the correct decision in relation to the dynamics of what's going on around you? So it's just like another layer of probability you've got to take into account.
Yeah, I don't know about, I'm not worried about right or wrong, except to the extent that the prediction matches what happens, I guess, or matches the real world probability distribution. So in theory, and as I said, it can go I haven't really, my simple agent isn't remotely complicated, so I'm just implementing a simple version now, but you know, I have thought through some of this stuff. So obviously you can have, you know, like as I said, if human predictions are both temporally blurred and probability-wise blurred, right? In the sense that they can have different values at a particular point in time. So in a full version of it, yeah, I'd be able to predict that I might die in, you know, that a particular event would have certain probabilities at different times. And you could fit all that into the algorithm, I think, fairly satisfactorily. As long as it matches the real world, what actually happens, then you've got it right, kind of thing.
Yeah, it would be interesting to put this into a little robot and submit it to Matt Crosby's Animal AI.
Well, that was the planned third stage of what I'm doing now. So for this paper, I'm probably just going to get my agent in the maze working, which is almost done, and I'm going to get it working on a simple machine learning algorithm to show it works with AI. But yeah, the stage after that would be absolutely putting it into. I thought about Matt Crosby's AI thing. It'd be quite nice test for it. Yeah.
Cool.
I was kind of interested in what it had come up a couple of times today, and the area of swarm intelligence, that the idea that there's a I don't know if you want to say consciousness, but it's not just the behavior, but the ability to infer or to make predictions and so on, it emerges from a swarm, from a network, from a group of entities or agents rather than just a single one.
Right, I spent years in swarm intelligence, and you must have come across the idea of the superorganism, which basically says that if you look at a social insect colony, you can treat it as one organism, and you can find counterparts to the sorts of cognitive abilities which you talk about in relation to a single, more complex organism. And I can't remember the guy's name now. He's an ant biologist at the University of Bristol, and he's really good at coming in with spectacular examples of what social insects can do. He almost got me believing in the superorganism. But I think what you can say is there are intriguing parallels, but I find I'm not happy to attribute cognitive abilities, but I'm quite happy to say that the results they obtain are similar to those that would arise from the use of cognitive abilities.
Would it fit into the extended mind stuff at all, Owen?
Sorry?
I mean, can you say, I mean, if you're willing to accept that my cognitive abilities are distributed in my environment with all that extended mind stuff, then couldn't you say that each individual ant's cognitive abilities are distributed within the swarm, so to speak, or shoal, whatever ants do?
Yeah, again, through hanging out with ant biologists 30 years ago, they pointed out that the brain consists of lots of little organisms, the cells, and they communicate just like ants do by transferring chemicals. into their environment. And therefore, we were, in fact, a swarm intelligence, and there's no point in denying it. So, but these things, you know, these are clever people. They're very ingenious, but somehow there seems to me to be some disconnect, some fundamental disconnect. Maybe I definitely couldn't go as far as attributing a form of consciousness to a superorganism, because there are no internal representations. It's all done by interaction between basically groups and the environment, which is very complex, and they can get the right answer as often as not, but the process is fundamentally different.
This actually, it spills over a little bit into what Eric and Micheline were talking about in terms of distributed systems and entities performing in concert.
Yeah, well, there's the flocking as well as the swarming. You know, look at Starling. Starlings are very popular at the moment, but there are satellites up there that they call swarm satellites that will reconfigure in response to a threat, or they'll actually form themselves into a parabola in order to read your car number plate. Don't quote me. So these are the things that go on, but at this frontier between the individually based cognitive systems and the collective intelligence, it does get on the borderline there. It's a fascinating place to be, but I spent years with these people, and they never converted me, but I learned so many things that are good to produce in a bar or a party or something like that. So they're all intriguing, but none of them are true.
What about slime molds? I was just wondering, are they still on the sort of collective side of the fence?
Oh yeah. Well, Andy Adamatsky at the University of West of England, who I recruited from Russia in 1995. He is the man for slime molds. Again, they produce results, but what you can actually attribute to them, I don't go nearly as far as what Andy does, but on the other hand, it's his bread and butter. So, but it's just all low-level interactions between distributed and possibly individually different things can produce these things that look like answers to questions, right? But you've really got to understand, when you understand what's going on, and the penny drops, you see that there was nothing really there. You were mistaken in your impression, but the inner process of cognition, that a parallel to that does not seem to be happening. You get the right answer through physical interactions and very simple behaviors. So, slime molds, colony organisms like Portuguese man of war. Bees are very popular at the moment. They seem to, there are ant algorithms, and now there are lots of bee algorithms. You just abstract them and find that they work really, really well, but you can't necessarily understand how they work, even when you've abstracted them. In the mid-90s, working with Ruud Sunderwoord from HP, we did an ant-based control for telecommunication, for load balancing and telecommunication networks. And it worked every time, and it was very, very good. But it was about 5 years before somebody managed to prove that it would work. And again, it's all down to low-level interactions, but this was just in tiny bits of code. So you could understand it as a kind of intuitively, but actually proving how it worked was really, really difficult. So, interesting area. I recommend it to anybody who has 10 years to spare.
So, Robin, you went galloping through a whole lot of stuff very quickly. There was, I think there was a few items in there that we could probably go back and revisit.
Before we do that, I would love to ask Owen a question. I always feel like we're set up as like foils, like everything I say, he says the opposite. And my question is just like, what do you mean when you refer to pure consciousness? Like, it sounds to me like you've become a Cartesian dualist, and I don't know that you want to take that on. So I'm just curious if you could say more about that first.
No, I certainly don't. I've never been attracted to philosophy. I think that's the way of the best way of putting it. But the thing is, I don't know. But intelligent people do this stuff, and then they come out of it and saying, "What I experienced was no self, no place, no me, pure consciousness." Right? And talking to these people when they're back in their normal frame of mind. You think, well, if I spent 20 years in meditation, several hours a day, I might well come to the same conclusion. On the other hand, the cynical part of me thinks that what you're actually doing is training your brain to have this illusion. And it's very hard to do. I think about all the things we get from embodiment, they're pretty well hardwired in. It's very hard to get rid of them. So I think that's the thing. But I think it may well be that there is a conscious state that has no contents except itself, right? I can just about get my head around producing that thought, right? But I can't get much further than that. But it seems to me to be an interesting thing to investigate. I mean, again, with Rafael Nunez, there's all this stuff about positions of numbers, and in pure mathematics, you know, you can trace it to, well, our arms only go out so far and we've got two of them and stuff like this. It's very intriguing stuff. But on the other hand, having plowed through Penrose's book, The Roads to Reality or whatever, which is about yay thick and so on, there was a lot of stuff in there where I thought, oh, where could this have come from? You know, it's possibly, it's not from the physical world. It may be an exaggeration of the possibilities of the physical world, and so on. So I do think that we can, you know, free ourselves of the bounds of Earth and humanity. And there is something, I don't believe that the objective truth is out there, you know, and we've just got to see it. I think it is constructed, but I think it can be constructed without reference to the body. So this is, I don't know if that's anywhere near an answer to your question, but well, I like Wittgenstein, and I think there's a couple of things he said. One was, it's impossible to set a limit to thought, because to do so, we'd have to think both sides of the limit. And I thought, that sounds like a mission for life, okay? And the other thing is that in the study of philosophy, one ends up making just some unrecognizable noise, okay? And I think it's interesting to think about these things, and I like to think about what could we do to find out, and so on. But my age, I'm not going to find out anyway, but at least I can hope to throw some grit in the oyster and hope somebody else might turn it into a pearl one day.
You always say you hate philosophy, but you're always talking about philosophy. So it's just, yeah. I feel like I want to say you need some Merleau-Ponty in your life, but you would hate it so much. So maybe you don't, I don't know.
We have all Merleau-Ponty's work through there because my partner is an artist and so on. But you're right, I just don't buy it.
Sorry, can I just interrupt quickly to Owen again? It is somewhat comforting to know that you also can't quite grasp everything. But so when you say that you consider pure consciousness to be without reference to the body, is there still something that you expect it to be in reference to, or is it entirely without reference?
I don't know. This is what other people say, right? And I would hope that it would be, it has to be supported physically, and that's a weasel word if ever there was one. It has to be supported by the brain, but not mediated through the body, right? So that is about as far as I can get there. So I know nothing about pure consciousness, but I can consider the possibility that it might exist.
Sure. Yeah, thank you.
Well, do you have a problem with considering the possibility that it might exist? Or is it with what it might be like?
Well, it's trying to wrap my consciousness around something that is beyond my consciousness, sadly. Simple as that. So.
No, I don't see a clear distinction between this fact that consciousness can be mediated or supported. So what do you mean exactly? Which is the difference between mediation and support?
Well, support is just like the substrate, right? If you like, it's if you think of the computer, there's the hardware and there's the software, right? And there's a big difference between the two. And the hardware supports the software. But what the software does is not derived directly from the hardware. It's not influenced by it. It's just the sea it swims in, if you like. So that's what I actually mean by that. So as Anil's stuff is much more directly that we experience with the body, right? And I think we experience a lot of consciousness with the body, but what interests me is the possibility that we might be able to experience consciousness without using anything derived from the body. Because if we can, yay, we're on the path to super consciousness, whatever that might be.
One of the problem with the notion of consciousness without referent or consciousness without content is that the without content, a lot of times, especially if you're coming from, say, Eastern traditions, Buddhism is kind of misnomer. It's more of a, it's less without content and more of a completely contentful. Like it's the content of everything. It is this notion of the unmediated experience is the experience of all things, right? Like this
unmediated by the body,
right? And so, but it's still
supported by the brain. Basically,
right.
The hardware is there, but what's going on in the hardware is nothing intrinsically to do with the body.
Right. And so, but the like, I would contrast Robin, and I would say that like digging further into Merleau-Ponty and then from there going into the post-phenomenologists might actually be up your alley, and talking about this nature of potentially the only kind of unmediated experience that we have is a complete mediation, is this complete integration with the apparatus of experiencing. It's again supported by, but not necessarily dependent upon. I think there could be something that you
in the religious traditions, this is the way they express whatever it is at the end of the rainbow.
The mystical, contentless content.
Yeah, and I've never experienced any of these, so I haven't taken enough drugs. I haven't done enough meditation, you know.
Hey,
but I know there for normal people to do stuff and have these experiences.
Yes, of course, you cannot discuss about any computational aspect of consciousness or pure consciousness. So it seems to me that it's completely outside any kind of computational aspects or computational model or whatever. So.
Well, having worked with swarm intelligence for a long time, I'm quite happy liberal use of the word emergent. Okay, so it is something that emerges from interactions of something and so on. It doesn't have to be logically derived from them. And there's lots of these physical phenomena that we know about. They just happen. I'm perfectly happy with that. Maybe I have low standards, but. But yeah, post-phenomenology, send me some name.
Yeah, Ian Hacking comes up a lot within that, the kind of framework that we're talking about here. And yeah, I can send you a couple of PDFs as well.
That'd be good.
Damien, you mentioned in the chat that you had forwarded the audio. That was just a recording of the type of talk that you had done, or is it something else?
No, it's this talk, the talk that I literally just gave. I recorded it on my end as well. So,
okay.
But apparently there was enough bandwidth and throughput problems that my audio kept cutting out for a lot of people, and I wanted to make that widely available for everybody, just more broadly, so that everybody could hear exactly what I was intending to say today.
Yeah, I'll watch out for that for that email.
Yeah. You know, one of the things that I did kind of want to get to, and I think it kind of touches in that the Robin, Owen, and David trifecta, and a lot of the Michelin as well. Like, it's everybody's. Like this conversation that we have actually been having today about embodiment and intelligence, and how intelligence comes to be, and like relationality, and whether it be relationality to like the environment that we're in, or relationality to other minds, or relationality to current state, to previous state, to future state. Like, this content has come up over and over and over again today. And this, I think, one of the things that we all kind of touch upon is that kind of, we recognize that whatever it is that we think of as intelligence or as consciousness, or as the, whatever the conjunction of those two things is, kind of comes about only in relation to something, if only in terms of your talks on pure consciousness just now, like even in terms of itself, it has to have some referent to something in order to express. But I think that that's something that's missing in a lot of the larger conversations that are happening more broadly, in terms of how is artificial intelligence going to, artificial consciousness, machine consciousness. I want to move away from the word artificial, but that's another conversation. This idea of machine consciousness, like, how does it come up, right? Where does it come about, and in relation to what? And I think that something that, in terms of further steps in a lot of this work, you can kind of put a lot of pressure on altogether from all of these different perspectives, is this concept of relational development of consciousness. This not just, about the body and the environment, but in terms of the social, in terms of the other minds that it develops out of, in terms of the ways that it predicts and what it predicts based upon, in terms of the ways that it works with a partner, in terms of the ways that it thinks, in terms of its own construction, its own embodied consciousness. Like, all of these things I think are of a piece. And I think that they can be used to put a lot more focusing pressure on the conversation that is being kind of danced around. This question of, like, Robin, you raised Dewey briefly in the slides that you powered through, but I think that John Flowers' work talks a lot about Dewey and the environment and learning and nature and relational content. But I think that there's a lot more, even out of the American pragmatism tradition, that we can kind of really bring that out of. And I think that that's kind of at the heart of what my talk was really meant to be about, was this idea that where we start from and in relation to what we learn and how we develop matters a great deal.
So Robin, I'm not opposing you in any way, because I spent a lot of time trying to build a robot that was as like a human being as I could make it, so that if it was conscious, it would have a consciousness as like our human consciousness. So I'm just an example of what Carl Jung called enantiodromia, which is that it's like reversal theory in psychology. Sooner or later, everything turns into its opposite. So it's just a natural process.
I think I saw your robot at the Science Museum in London a couple years ago.
Yeah, there were half a dozen examples of the whole sequence that had been invented. Yeah, it started off as an attempt to build a conscious robot, and in the process we built an unusual robot, and then I wasted years of my life trying to make a better unusual robot. So, but they liked it because it looked cool. So
it did look cool.
And if it had had consciousness, it would have been very embodied.
I was very intrigued by the choices of like the single, had like a single eye, right? It was, was it Kronos? Was that what it was called? I forget.
That's the one that David spent a lot of time with, because he was actually doing his PhD, or one of his PhDs, on trying to detect the signs of incipient consciousness in actually a simulation of the thing moving its eye. This was the thing, but nobody seemed to mind. They'd say, "Oh, that looks creepy," and then they'd accept it, and people would accept this thing without a face and without any skin. There were no problems. We didn't. People would say, "Why doesn't it have this and that and so on?" I said, "Well, they're not relevant to what we're trying to do." And there's a snippet for you. I had to give a talk on it once at a conference in Cambridge. What I didn't realize when I went there was that it was a feminist conference. And after my talk, I was accused of making an aggressively masculine robot, right? And I said, it has no features, and all the measurements were taken from my robot builder's girlfriend. Didn't make any difference. But people we're quite happy to attribute attitudes, character, and even gender to this thing, so, which shows just how hardwired we are to respond to those things.
Did it have a model of attention built into it? I remember it looking at salient features of the visual field, which probably gave it some of its humanness.
Oh yeah. We had the Itian cock. Basically, it would find something in the visual field that was high contrast or moving or attractive. It would look at it, and after 10 seconds, it would get bored with that, and it would look at something else. So you could put it, and also you could program it to detect faces. So we set up the eye with a big screen above it, and people would see who it was looking at, circled on the screen. And you could see people brighten up when it was looking at them, and when it moved away. They were totally passive, but it doesn't take much.
I remember being excited by some of the materials you used for those robots, because they were like the musculature and stuff was, I don't know what it was made of, but when I looked at it, I was really impressed because it seemed like the materials drove more of the way that the thing moved in the world than just the programming.
Oh yeah, it was almost all due to the number of joints there were, the huge number of degrees of freedom, and due to the elasticity, the intrinsic elasticity, because we could shorten or lengthen this amount, but it was elastic. So for example, if you raised its arm at one side, you could see a wave propagating through the thing, and it would come out of the other. So it's and doctors were very interested in it as well, because it was like somebody with cerebellar damage, because it didn't have any of the positional feedback. So it would move very jerkily. So, you know, cheap, but informative to people who knew about the human body.
This is one of the
I have a little, sorry. I have a little question for David. And so what do you think about the transparent process related to the prediction? So it is, a machine is intelligent if it predicts something, if it predicts a situation, but in my personal opinion, I think it's very important that the machine is able to explain why it reached some results, why it predicts that situation in a way. So I think that inner speech could be a means for this kind of behavior from the machine. So what do you think about the transparency of the process during prediction?
Okay, so I mean, so part of this whole approach, part of the approach is, I mean, I've been taking a kind of internalist approach with this. So that assumes that you can look into the machine and find its internal states and all the rest of it. So that's So in that case, it's transparent in the sense of you know what the machine's predicting, but you don't know why it's making those kinds of predictions. And I'm guessing if we're taking something along your line, your approach with the inner speech, then that would be, it would be presumably using its inner speech in order to generate the kinds of predictions about what was going to happen next, or to understand its environment and stuff, if I'm correct, yeah? So I haven't really concerned myself at all, just because it's not been what I've been focusing on about how those predictions get there, but I've sort of assumed they're inspectable to some extent. But I guess related to the transparency question would be, you know, there might be cases of systems whose representational states are opaque and maybe couldn't be probed. I mean, it's unlikely. I mean, even deep networks can be probed to some extent, but then obviously then you just got to rely on external behavior to measure the predictions. And so there are possibly sort of blind spots, if you like, in this approach in relationship to AI safety, I think. So does that roughly answer your question, or not? I missed it there.
So no, yes, but also I want to say, if you consider the possibility to provide the machine with a form of intelligence which explains the way, so if the machine is a black box which computes probabilities, distribution of probabilities, it is a not meaningful way for understanding what are the underlying decisional process of that machine. So I ask you if there is a possibility to explain this procedure, this mechanism, and why the results correspond to a specific input or another kinds of input. There is a way for explaining, for overtly produce this explanation.
Maybe, at least in my own opinion, I think these are sort of orthogonal problems in a way, right? There's the sort of measurement of the intelligence or the ability of system to predict, which is kind of what I've been focusing on. And then obviously, as you say, there's a lot of complicated issues related to kind of explainability in AI and trying to explain why the systems act the way they do and all the rest of it, yeah? So prediction can play a part in that, I suppose, if you know that if the system has, you know, these particular mappings between motor actions and expected sensory inputs, then that could play a part in explaining, you know, why the system acted in the way it did, because you could say, well, it's predicting that it's going to get the reward in five seconds or something if it does these actions. So then you'd understand that it did those things because it made those predictions. So predictions can be an explanation for action in the case of where agents have specific goals, and it could certainly fit into that framework, but also, you know, also the sort of mechanism for generating those predictions in the case of, let's say, a face recognition algorithm is really, you know, just a deep net or something, a black box of some kind. And there's a set of different mechanisms you have to use that are sort of, as I said, orthogonal to the prediction. You'd have to use to sort of probe the network and understand why the weights were set the way they were, and maybe look at the training data and all that kind of stuff. So I think it's maybe it overlaps. Maybe it's not orthogonal. Yeah, maybe it's more of a Venn diagram sort of overlap thing. Yeah. But I certainly agree with the relevance.
Yes, it does. As you're probably aware, that there's been a series of DARPA programs on explainable AI. I haven't looked at recently at where they are, how far they've got, but the whole process of like the inner speech that Ariana was describing is some of this has to be a record of the reasoning that the system has come to in order to explain how did it come to this conclusion. Well, it is that inner speech is part of it, isn't it?
Yes, I think that a usable objective of inner speech is to explain the underlying decisional process. So it opens these research outcomes that could be very important for the artificial intelligence in general. I don't know if by inner speech the system becomes more conscious about its internal process. I don't know if it's possible to claim something of this kind. So inner speech makes the system more conscious of this of its process. I don't know.
I think there's probably some theories linking inner speech to consciousness. I mean, it's not really my area, that the speech and consciousness thing, but I'm pretty sure if you looked into it, you'd find some. And there's also all this higher order thought stuff. So maybe it fits into the metacognition, the relationship with that and consciousness, perhaps. If you're interested, there might be stuff you could find there.
In that scope, I would actually recommend taking a look at the work of Ruo Williams. They work on autism, game development, speech and communication, specifically looking at autism and AI. They are themselves autistic, and they look at this from researcher and a lived experiential perspective. So thinking about the communications aspects from that perspective might be very helpful. They just started working at, I don't remember which university in Indiana, but they just moved up there.
I did have one item that that we probably, I'm just keeping an eye on the clock here. One item that we might want to briefly touch on is what sort of plans do we have or for next steps. We have, as we mentioned at the beginning, we've been recording this session, and this will be part of what goes into the event in the Euroscience Open Forum. But in terms of proposing additional workshops or getting together virtually or in the real world over the next year or two, I don't know what sort of plans anybody has. At the moment, all I know is that the Robo Philosophy conference is next week or 2 weeks time, I think. But I believe I'm assuming that it's mostly virtual. It was planned to be held in Aarhus, in Denmark, but I don't know anything about it. What other events any of us might want to campaign for, or proposals for future activities.
I mean, it's a good time now to do this kind of thing, I think, because, you know, like we have this meeting, right? And travel's cheap now, right? We can just have a meeting like this. I mean, it's not ideal, right? I prefer to go for a beer, but, you know, it's you know, it's still, you know, we can think in terms of organizing stuff next year, because I don't think the situation is going to change much. So, yeah, I'd be very happy to do some kind of machine conscious thing next year. I mean, Antonio's got some ideas about that already, right? So, yeah, we can put it together into a slightly larger event or something. I'd be more than happy to, you know, be involved with something like that.
I think that we can organize, as we mentioned before, we can organize some kind of meeting in next April or next spring anyway, more focused on 2 or 3 theories of consciousness and trying to compare and find some kind of experiments or something like this. This could be an outcome of the proposal that we submitted that was not accepted from the to the Templeton Foundation, and some kind of adversarial theory, 2 or 3 theories, and find some kind of experiments, and so maybe more focused workshop. And on the other side, in 2 years, but we don't know what will happen. In 2022, there will be the IGCAI in Milan. IGCAI is one of the most important conferences in artificial intelligence. And who knows what's happened, but it could be possible for me to organize another meeting, more traditional meeting. Who knows? I don't know, actually. As I mentioned before, my plan is to organize next spring this kind of workshop as a kind of outcome of this proposal that we had at Templeton, and we can try to submit a special issue of the journal for we can fix a deadline for around half of November, and as a concrete outcome of this workshop. And I don't know, actually. if there are other initiatives.
Well, I suppose part of that it'd be to set up a special issue of the journal. What we would be saying is basically each of the talks that we've heard here, that the authors would turn those into a short paper, right?
Yeah, something like this. Yes, we should, short or long paper, we don't know, but not too long actually. Yes, each one of us could prepare a paper, also taking into account, of course, this discussion. So it seems to me that we touched many interesting points during discussion. So it would be great if some part of the discussion could be part of the papers, of course.
So will you send us around a reminder or something about when the deadline is for submitting the paper and all that, Antonio?
I think that we can fix the deadline in the middle of November, because everything should be ready for the end of December. So I think that if we submit papers in middle of November, that we have more than 1 month for review and for eventual revision and something like this.
So you want a short paper by middle of November, short like a few thousand, 4,000 words, 5,000 words, that kind of thing, yeah?
Yeah.
Okay.
Yes, yes, more or less.
Some of you know I've been thinking about whether we should try and set up some sort of center for machine consciousness or artificial consciousness and so on. Instead of a center, I think it would be more like a circumference. But if we can set up something that would persist for over a period of years, because I remember when in the early days of talking about machine consciousness, there were quite a few meetings, and there was a hardcore of us who used to meet up at these meetings, so we didn't have to set anything up because there were enough events to go to. And now it's a bit more sparse, and with the pandemic, it's more difficult. But I think it should, it seems to me this format works much better than I ever thought it would. And so if there is a center, it should be a virtual center. So but it may be worth exploring as an idea. And it would be free.
Yeah, we know.
But probably a good idea to keep it separate from the journal, since the journal is the publisher's thing. Some kind of committee or whatever that preferably everybody was on. I like those sort of committees.
We have to think about it. We have to think about it. I don't know, actually. At the moment, I don't know. Anyway, we have to think about it. So.
I have plenty of time.
Although it may be quite a virtual center, as you say, and the get-togethers are in some measure anyway like this. There still would need to be a sort of an institutional home, right? So somebody, some real-world organization has to be the owner of the Zoom session and the website and all of that.
Yeah, I'd put that off for as long as possible. We can hover until we start running out of fuel and send somewhere. But they wouldn't have to do anything much, and we'd have to make sure they derive no benefit from it whatsoever. But there would be noises from people like the chair of computer science at Oxford, for example. Not that they would do it, but I think it wouldn't be too difficult to get influential endorsements for the idea. If anybody belongs to an institution that, well, they're all going to be on their uppers because there'll be no foreign students for anybody anymore. to wait a year for the situation to sort itself out. But we could at least, I think, start bouncing the idea around. But certainly having something like this every 3 or 4 months with a small group of people presenting, they could circulate a paper, do a talk, and then we could have a discussion. And then some of this might filter into a convenient journal, for example. There would at least be a website where things could be put. And basically, eventually, this would crystallize or congeal into something substantive. It's just a thought, but I feel that, you know, that the sap is rising. We've got there's nearly 60 people, I think, on the editorial board of the new journal, Antonio, and quite a lot of them are American, which wasn't the case. If you remember, in the early days of machine consciousness, there was not a lot of interest from the States. It was mostly a European game.
Yeah, I agree with you. In any case, the publisher wanted to review the editorial board every 2 years. So at the end of next year, we have to review and see if there are only names or there are people that are really interested and want to do some work. And the current, they asked me to, in any case, to drop a lot of people and to have no more than 30 people. So in every 2 years we have to review the number and how many people there will be in the editorial board. And they recommended me to go no more than 30 people. Yes, I agree that essentially this stuff of machine consciousness started more in England than in Europe anyway. There are many people from England actually, and I'm trying to, in some sense, to take into account people from Europe. For example, there is in France, there is Raja Chatila, which is a big name in robotics, in AI, wherever, which is interested in machine consciousness. And recently I was contacted by a German person that is interested in machine consciousness, is producing a kind of interviews on machine consciousness, is preparing, he had some funds, he had some money for preparing a website, collecting interviews in people interested in machine consciousness. And I would be really interested, my main goal is to get more people from Europe actually, and even because we can prepare a European project or whatever such as this.
Yeah, well, but we're just leaving Europe, you see.
Yeah, you are leaving Europe anyway. But I know actually it happens to me to review a project from the EPRC, or what is the name of your agency. Sometimes they are related. There is some relationship with machine consciousness.
Yeah, we'll see.
You have a lot of money from your government, actually.
But I feel more optimistic now than I've felt for years about the prospects for the area. Even though we haven't actually done anything.
Well, I suppose built into this, as well as the sort of the research component or the workshop component, presumably there's also, I imagine there should be some sort of a like a curriculum development as well, right? That there's an opportunity to actually reach out to students who may be interested in pursuing this and teaching a course, and which presumably would be something like reviewing various various positions and reviewing papers and so on. It would be. It seems like it would be good to be able to provide perhaps it's an online set of lectures or set of courses.
Yeah, good idea. It might attract an institution, but it would get more people, well, aware that it exists. And
yeah.
Not everybody is crazy.
Like a sort of micro degree or something like that, or some kind of open university thing in the UK context. I mean, what sort of thing would you have in mind offering?
I don't know. I mean, I'm just sort of thinking out loud here, but it feels like that there's a something along the lines of the type of things that are offered by Udacity or Coursera, or those sorts of things, where there's a consolidated set of lectures with readings and exercises and so on. Somewhere along the way that
consciousness.
Huh?
Principles of machine consciousness.
Yeah.
The problem is that obviously an effort like this one should be founded by someone, because there should be a point of view from philosophers, from psychologists, from computer scientists, even from neuroscientists. I think that there could be something which is not only related with one category of experts, but huge categories of experts, from neuroscientists to philosophers, psychologists, and computer scientists, roboticists. And
well, let's brainstorm it in various ways. I think the best we can say at the moment.
I mean, rather than a course, another option would be something like, I don't think we even have a YouTube channel, right? I mean, where you could bring together, lots of different talks and perspectives, into a single place. I mean, there isn't really any kind of, at least I'm aware of, any kind of single resource for finding out about machine consciousness, unless I might be wrong about that. Yeah, because
machine consciousness, the facts.
Huh?
Machine consciousness, the facts.
It just happens, right? Yeah. But I mean, now we've got this, great journal, right? It'd be good to have I mean, the trouble with the course, I mean, I like the idea, John. It's a great idea, but obviously someone's got to have the time and the effort and whatever to put it together.
Not for you.
And I've got no time, yeah. So, none. so it's that's the problem. Whereas something a bit less formal, like a YouTube channel, or when Owen's got his organization going, that could be some kind of framing device for that. Then you can share things like this workshop on it, and then you'd be aware of people who want to find this. There'll be a single place where people can look for more information about it.
Anyway, this workshop would be distributed by my university in their webpage.
Oh, so in that case, your university is going to host the center and run everything for us, right?
I heard him say that.
Well, I was going to propose either University of Palermo, or alternatively, Damien, in his copious spare time, could handle this whole task.
Yeah, I'll just take on all of that, and I just need you all to sign a couple of IRB forms so that I can secretly use all of this as ethnographic research towards the PhD. Creation of an institute comes an entire 3 chapters. Yeah, that.
Ideas coming out now.
No, but the idea of I can say, of a tutorial book it could be a good idea. So some kind of a textbook of machine consciousness could be a good idea with exercise and so on. We discussed it many years ago with Igor Alexander, I remember. Obviously, it is a huge effort. So we need some kind of award, some kind of grants.
Yeah, as I say, but if we brainstorm all these ideas and then filter them, we can come up with a core.
Yeah, but we need to do some exercise. So you have to propose exercises and.
Yeah, or it could be incorporated into an MSc on AI, for example. I mean, that's the other approach in terms of courses, right? So for MSc in AI, at least in Middlesex, you have like 4 modules. One module could be on machine consciousness, right? That'd be sort of very sensible, right? Middlesex is MSc on AI at the moment, but other institutions with interest might be interested.
To that end, and on a serious note, the Virginia Tech just opened up a Center for Technology and Humanities, and I know the guy that runs it. He's very interested in questions of AI and technology and consciousness. So I think Virginia Tech, having newly allocated some kind of funds, would be willing to. I doubt they'd be willing to host it and take it all on their own. But in terms of linking together with a couple of other institutions in the way that you're talking about, David, I think that they would be interested in being a part of something like that.
Yeah, that's certainly worth considering. Yeah. Can you share the link to it on chat, Damien, just so we can have a quick look at it?
Yeah, please share the link. Yeah, of course.
Antonio, the other session that I was running, that I was the host, that session terminated, that login terminated. So you're the host from here on.
Okay.
I'm not sure what else we need to cover at this point, but and anything that anybody has as far as the various presentations and things are concerned, you'll be able to host those, Antonio, get them onto that website.
Yeah, I think so. I will provide a link to the register to the. Okay. Owen is back. Yes, I will provide a link for this session.
Great.
Well, I'd like to thank both of you for organising. Yeah, Antonio and John, much appreciated. Thank you for inviting me.
No problem.
Very much agreed. Thanks, Al.
Just a little bit of cat herding.
No, actually, John made all the work. Actually, yes. Okay, so we can meet again if you want in September at the Trieste meeting. Actually.
Yeah, that's true. I'll send the information about registering. I don't know what the registration process is for people who are not presenting. In fact, I don't know anything about the registration process at all. So, but that's our next step. We can certainly get together there.
Okay, and in mid-November we can expect to have the papers for the special issue, and then we'll see.
Yeah. You'll send an email around, I'm sure.
Yeah, we send an email reminder, of course.
Okay, wonderful.
Okay.
Great. So it's just about lunchtime here. So
yeah. It's just time for us. Okay. So thank you.
Great.
Yeah, thanks.
Thank you.
Bye.
Thank you, everybody.
Bye. Bye, everyone.
Bye.
Good luck.